Standard algorithms. What are they? Well, a standard algorithm is a set of program instructions written in a prescribed sequence which perform a specific task or action. At National 5 level, you will study input validation, running total within a loop, and traversing a 1D array. At higher level, the standard algorithms that are studied are find minimum, find maximum, count occurrences, and linear search. At higher level, 1D arrays and arrays of records as well as subprograms are used when working with standard algorithms. But whatever level you're currently studying at, what you need to remember is the SQA always write questions about standard algorithms in exam papers using reference language. You need to be able to not only read and interpret questions which have been written using reference language and identify them as specific standard algorithms, but you also need to be able to solve programming problems by implementing standard algorithms as part of your solution in the programming language of your choice. We are currently using Python for this. So what are the advantages of standard algorithms then? Well, it makes reusability easier, which means you can write a subprogram that implements, for instance, finding a minimum value in a set of values, and you'll be able to call that subprogram again and again. So you've only written the standard algorithm once, but you can reuse it. Also, it helps you to read your code, and especially if you've not written the program but you're expected to update it, then it's easier for you to be able to read and understand what the program is actually doing if you can identify sequences of code which carry out specific functions. So let's start off by having a look at input validation. Now here is an example which has been written in reference language. So let's kick off by understanding what this reference language is doing. So it says receive quantity from keyboard while quantity is less than 1 or quantity is greater than 3, do. And indented is what is the do part. So you can see that this is a while loop, while, end while. And if this complex condition is true, evaluates to true, then the two lines indented inside this while loop will be executed. If this condition here is false, then this code will never execute and the while loop will terminate and the program will move on to the next line of code underneath. So we can see here that it's checking what is stored in this variable quantity. So there is a variable here called quantity, and it's just been updated from something that the user has inputted at the keyboard. Now quantity is being compared to 1, and if the value currently in quantity is less than 1, or if the value being stored in the quantity variable is greater than 3, then a message is going to be sent to display, and the message is written in these speech marks: error, re-enter quantity, must be between 1 and 3, and then received back into the program from the user re-entering. The variable will receive whatever the user re-enters. And because this is a while loop, it doesn't terminate when it gets to this line. It goes back up and checks this condition. This is called a conditional loop, and it's only when this condition evaluates to false that this loop will terminate. So the user could constantly be re-entering if they keep inputting a value which is not valid for the program. So let's have a look at this in Python then. I have created a Python file and I've opened it up into the Thonny editor. Remember, Thonny is free. You can download it from the Thonny website. Okay, so here is the standard algorithm for input validation, and it's been written in reference language. So I'm going to interpret this and implement it in Python. So the first thing I want to do is put a single line comment into my program with my name, the date, which is September 2020, and then a multi-line comment explaining what this program code is about. So this is an implementation of the input validation standard algorithm. And then we can get started. So we need to declare variables, that is reserve memory locations in RAM while this program is executing. And we also need to tell the computer what data type to store in these memory locations. So we know that we're going to need a variable called quantity, because we can see it here, receive quantity from keyboard. So quantity will be an integer data type. So we'll say integer variable, because we know that it's going to be tested to see if it's less than 1 or greater than 3. 1 and 3 are integers, they're whole numbers. Now we can implement this first line, receive quantity from keyboard. Now in Python, well, this is an assignment statement, first of all, isn't it? Quantity will be assigned the value which the user enters from the keyboard. And remember, it's going to be an integer value. So quantity is assigned. We're using the assignment operator, and we're using the input function, which is a built-in predefined function in Python. And the message which goes in as a parameter here is what is displayed on the screen. And the user enters a value which is then returned to the program, and because of this assignment statement will be stored in the variable quantity. So we must make sure it's an integer value before it's stored. Input returns text. So what we need to do is use the int predefined function, which will cast the returning string as an integer value, and then that integer value will be stored in quantity. So let's finish this statement off by entering a message. So enter a quantity between 1 and 3. Okay, so that's receive quantity from keyboard. That's that line implemented on line 8. Next, we move down to this while loop and our complex condition here. So in Python, it's while quantity is less than 1 or quantity is greater than 3, colon. It's indented, and it says the next two lines are send and receive. Now we can achieve both of these lines with one input statement, which is part of an assignment statement. So quantity is assigned int. Remember, we need to cast it as an integer, so we're using this int, and inside it we're putting the input, and inside the input we're sending this message, error, re-enter quantity must be between 1 and 3. Error, re-enter quantity must be between 1 and 3. Finish the speech mark. And that will be returned to the quantity variable, and that ends the while loop. So in actual fact, this input validation is 3 lines of code. The initial receive the quantity from keyboard, and then the while loop. Now we need to test this to make sure it's working. So I'm going to save that and then F5 to run it. And down here in the shell we can see the output while the program is running. Enter a quantity between 1 and 3, and if you look at line 8, inside the speech marks, that is where you're seeing that text, enter a quantity between 1 and 3. And the cursor is flashing. When I type a number in here and press enter, this line of code will completely execute, and the value which is typed in here will be stored in this quantity variable. So I'm going to put in number 4 and then press enter. And I put in number 4 so that this while loop would be true. Quantity is greater than 3, so that's true because I've put 4 in, so 4 is greater than 3. And that means that this line 10 has executed. And you can see that it says error, re-enter quantity must be between 1 and 3. Error, re-enter quantity must be between 1 and 3. So I'm going to put in 2 this time and hit enter. And you can see that the program has terminated. You can see down here in the shell, the 3 chevrons are telling you that the program is no longer running. And that would be correct because underneath this while loop there are no more instructions to be executed. So that tells you that when I entered 2, this condition became false and the while loop did not enter line 10. It bypassed it, and because there was no other lines of code, the program terminated. So this is working correctly. Now you can see the power of this. As soon as the user enters a value, you're validating it to make sure that value is acceptable by the program. If it isn't, you continually, that's why we're using a while loop, you continually ask the user to re-enter a value which must satisfy this criteria. Now, you're checking for the user putting in a wrong value so that it triggers them being asked to re-enter. When they put in a correct value, a value that is valid by the computer program, then you don't want this while loop to be executing. You want it to bypass it because you are actually going to accept the value which is currently stored in quantity.